The motor rotates in steps and completes its rotation in steps. So we could see the red blocks across the stepper motor, one by one they are glowing, which means it's an indication that the port pins are giving signals and making the stepper motor to run in steps. So on to the desktop, we have clicked on the Keil Microvision 3 version, which is free version. Click on the project option and choose new project. Name the project with the appropriate name as per our choice. We can name it. It's a stepper motor program. So save it. We have saved the project. Then we have to choose the target option. Select device for target 1. So it's ATMEL, ATMEL. We have clicked on it and we will choose the appropriate microcontroller needed, 89C51 or 8051. Clicking on the No in the pop-up window, we proceed further, and this is the screen that is visible. Click on the File option, New, and then this is the text editor window wherein we are supposed to write the program, 8051 program. The program we are going to write will be in embedded C. We have saved the program. Earlier we saved the project. This time the program stepper motor dot C extension, because this is embedded C program. Save the C file, embedded C program, and then start typing the actual program. #include reg51.h, that is, we have included the header files required, reg51, the registers of 8051 that we will be needing. Set the bit, S bit, initially L1 through port P1 we are going to output. So here L1, L2, L3, L4 will be the lines connected from microcontroller to the stepper motor. Then we are making use of port 1, which has been connected to the stepper motor, port 1 of 8051 microcontroller. The 4 pins are as shown here. Then we have completed with the declaration statements. Now starting with the main program, void main void. So initially L1, L2, L3, L4 we are going to out binary 0 through 8. We are making use of the while loop statement, which means an infinite loop. While the condition is true, the loop is going to get executed. We need an additional integer I, and that's why we have declared it as unsigned integer I. Let's proceed further. So step by step through each and every lines that have been connected to the stepper motor, that is L1, L2, L3, L4, we are going to out binary 1 at a time from each of these lines so that the signal reaches to to the stepper motor. Initially, we have made L1 equal to 1 and rest all other equal to 0. We have called a delay, wherein the delay count is 6, 4 times 0. Again the same 3 steps. In this way, the 4 lines from the output port of microcontroller to the stepper motor will be assigned the signal binary 1 at a time, and that too after a delay count of 6, 4 times 0. The program is over. Click on the target. We get the option source group 1. Click on it. Add files to the group source group 1. Name was stepper motor. We have selected it. Add it. Close. Click on the source group 1. You can see the stepper motor.c build target. And then we could see 0 errors and 0 warnings because the program has got executed. We have clicked on the target 1 option and the exact frequency that has been provided to the 8051 microcontroller 11.0592. We have set it, clicked on the options provided as like, and then we could see 0 errors and 0 warnings. Further, click on the ISIS professional so as to see the demonstration. P, we are clicking on the P option so as to add the devices, that is pick up the devices or pick up the components needed. So we need a stepper motor and a microcontroller. So we have chosen a stepper motor, and then earlier we have chosen the microcontroller. So we could see 8089C51 microcontroller and then the stepper motor. We are placing them on the screen. This is going to be our virtual demonstration how the circuit works. As per the 4 lines of the port pins P1, we are going to connect it to the stepper motor. Those were P1.0, P1.1, P1.2, P1.3. We could now select the hex file which is stored in our drive, steppermotor.hex. Open it. The clock frequency 8051 is 11.0592. The same we are going to type it again over here. Click on OK option and then click on the run, that is play button, wherein the stepper motor could be seen rotating in steps. So this is not a continuous rotation as like in AC motor and DC motor, because it's a stepper motor.